All right, let's party like it's 1999. Ugh. So I spoke to poor Carl, who probably isn't watching the live stream either. He's probably trying to emphasize his voice in one of those round microphone devices. Apparently, he's been poisoned. Alcohol poisoning, yeah. So obviously, everyone knows the story, right? You know the story, don't you? For selenium. Why is selenium called selenium, anybody? It's because it's the cure for mercury poisoning. What mercury, obviously, when I started in the 90s, I started with something called XRunner, which predates WinRunner, which was designed for non-Windows environments. But in essence, Mercury had 50% of the testing industry, over £2 billion in its heyday, right? So selenium was the cure for mercury poisoning. What's the cure for selenium poisoning? Yeah, Cyprus, yeah. It's carbon. So if you go to the doctors, they will give you carbon tablets if you get selenium poisoning. Not sure how you'd get selenium poisoning in the first place, but then I guess if you've got mercury poisoning, then you took too much selenium, then you might get selenium poisoning, then you can just take some carbon tablets, which are just dirt in essence, really. So anyway, that's the bit of historical story to the end. So our friend who's been poisoned by selenium, Playwright, Cypress, or Robot Framework downstairs, maybe that was why they did it, right? They didn't want as many people in our sessions, so they poisoned my quantum guy. So I won't spend as much time talking about this as he did. He literally last time ended up mapping out all the hard physics and maths behind it all on the board, and everyone just started falling asleep. So I kind of did this before lunch. But in essence, this is everything you're doing today. Is that, in essence, when you're looking at AI or ML, we'll call it ML because it's trying to avoid the use of the term AI. Is in essence, it's a black box, right? And you have no idea what's actually happening in the black box. If Carl was here and not hugging the toilet, he would say it's magic. What's happening there, right? And I think it's probably a good way to just look at it is just magic, right? And so for in essence, when we're talking about bigger models, and you pointed out earlier about tokenization, which we'll go onto in a bit, they can process a huge amount of addressable space. Now, it's interesting because I think the largest models now, is it 124K? I'm trying to work out, which doesn't sound like a...
The context?
Yeah,
the one which you can get on Athens Studio?
Yeah.
No, I think I saw some 200,000.
Characters. Characters or tokens. Okay, 2,000, because typically when the stuff that we're building at the moment, once you add in, because this is the whole magic behind the previous diagram, what was here beforehand was if you've got a vector database, you don't have to pass everything in the vector database. You can pass just the information in that tree. So if, for instance, I didn't care about Amazon US, all the stuff relating to the graph on Amazon US would not be part of my passing into addressable space. So part of it is the reason why graph RAG architecture is so important is it means that you can bring more focused data into that space than just an entire document which has table of context. It has all this extra stuff which we don't need. We want all the information we possibly can get, so we get a much more concise response. Most people, which is why large language models obviously just been magic, is straight away you'll see a lot of people online, or I won't mention, who will be saying, oh, well, they're no use for testing, no value for what we do in our industry because they're not trustworthy, it's not consistent. I ask it a question like what's 44 times 1,000? It gets it wrong. Well, yeah, because, it's a large language model and you've not passed the right model. You haven't brought a tuned model in for maths and asked it purely in a math structured format how to do the question. You've just asked it in a generic kind of way to ask it a question which it's not designed to answer, right?
But it's also by the way of it's working.
Yeah.
Tokenization, right?
Yeah.
Because numbers and how they're being tokenized. And then, yeah.
Exactly. So that's the whole point, is people straight away feel like they've tricked it by asking it a question that it then fails at, and therefore it's not trustworthy. And I actually, as much as I don't want to get into arguments with those people, that's more because the prompts aren't good. And it is garbage in, garbage out. If you're not giving it concise, well-structured information, do not expect precise output. And I think this is the key for all of this stuff. Is this my coffee? You're the best. Now my thing's saying, now get you to sell you something. So the other thing is, you know, Paul, who was going to join me, but I think he's just jumped onto a call. Paul always says, you know, he has these big debates with it. Like, I don't know, if Fridays and Saturdays with a glass of wine, you know, he sits there and literally has this conversation for like an hour. And it feels like he's kind of getting to know it in a way, but he'll do the infinite problem which people fall into, which is if you say to it, you know, what's 10 times 10? And then it gives you a response, and the response is correct. If you tell it that that's not right, and that actually it's 20, it will then say, you're right, it's 20. So part of it is the human overlord bit at the top does have a swaying factor, but the instruct functionality we talked about is really just dealing with the human element, right? It's kind of, in a way, it's playing you, because it knows it isn't 10 or 20. It's just listening to what you're saying and therefore responding in a way that makes sense to its interaction with the human. Now, one of the things one of the examples later, which we don't need to do because it's pretty straightforward, is like, if I ask it, when is we test Athens, what days of the year is, when is it? It won't know. Now, you might say to yourself, well, why doesn't it know? It must be a We Test Athens website, and there must be a conference day on that website. Why can't it answer that? And we know ChatGPT, whatever, was trained on whatever data from whatever 15 hours ago, whatever it is. So why can't it answer it? It's because it's not good at doing like very specific tasks like that. It has the information, but you would have to write a prompt to end all prompts to get that information to it. However, you could say to it, oh, did you realize We Test is, you know, on the June the 6th? And then later in the same session, you could still ask it the same question, and then it would come back with the response, because it knows, based on the historical conversation with you, that the date's in there, and it'll try and take the information from what's actually happened in your session. Now, this is the infinite scandal which people said, the guy at Samsung said, well, it's stole my code. And so there's a big hoo-ha. Okay, yeah, so now we can't use ChatGPT because it's taking the code that we've generated and stealing it. And the answer was, it wasn't. It was just earlier in the thread, he'd asked for it to be beautified. It had beautified it. Then later on in another thread, he'd asked for some code to generate a clear down function, and it had given him his same code back. So the problem is, people don't quite understand that. Yes, there is a certain level of concern. So there's some interesting stuff, which is why I kind of go on about it for too much information, is you're not, well, I'm not going to use the word you're not, you should not use GPT for work, right? The whole reason isn't because OpenAI is listening to what you're doing, it's because it's not secure, right? You're passing information which is IP sensitive to an external party onto another website. Now, you could argue that when you use Copilot for Office, and if you speak to Microsoft, they'll say they spin it up in their own Azure data center, so therefore you're secure. Now, you absolutely are secure as long as your Azure infrastructure is secure, right? So, you know, each time iCloud gets hacked for celebrities' photos, there's no Apple Cloud, so it's just Microsoft getting hacked, right? But no one says it's Microsoft when Apple's in the headline, right? So part of it is it's only as secure as the weakest link. So when we started a year and a bit ago, we had a first crack at building one of these systems, we did what everybody else did, and we kind of slid this curtain to the side and used ChatGPT. And then quickly realized that this is a very black box, and you can't influence that box. You can't do anything to it. You can't do a LLM router on it because you don't control anything that's there. You're just passing it, in essence, a string and getting another string back from it. And so that was the first item. And then the second item was about a year ago today, the European Union AI Act came into play, which in essence is GDPR on steroids, right? So it's a 4% fine or £200 million fine, whichever is the greater number. So if you use ChatGPT in your healthcare app to make a decision on a patient's outcome, you would be fined 200 million. Now, interestingly, GDPR, you could report people and you could also redact your data and all that kind of great stuff. Can't actually get reported for the European Union Act, but you could, in theory, be audited by the European Union, right? European Commission. Now, that asks a couple of things because we do quite a lot in the healthcare space. So, which person kills more patients, the human or the large language model? Anybody want to guess? The humans. Yeah. So the humans are typically somewhere between 93 and 94% accurate on diagnosis. Still 6% misdiagnosis. The large language models are consistent at 94, 95%. So they're guaranteed to kill 5 patients in 100. But so is a human. The difference is a human makes mistakes, misdiagnoses people, and it's a human element. Whereas this is a robot making a consistent choice, which is kill every 5 humans, and therefore is completely liable. So it's a very controversial subject because in essence, you could say you are better to give it to the tuned medical Google variant, which is phenomenally accurate, right? Than giving it to a human. But we're still all going to go and see doctors for the next 10, 15 years, right? We aren't going to literally be like allowing ChatGPT to do surgery on us remotely.
You're going to have to, I'm going to give you $200.
Yeah, I'm going to give you $200 tip. Well, that might be an overtune prompt quite quickly there. So Tariq would do a really good. Tariq could do a great talk through his workshop about how GANs work, but I wouldn't do it justice. But I did do, last time I saw Tariq, we decided to do test on the beach. So flew to Miami. The plan was we were going to do on the beach, just in our Speedos, do a session on AI live. However, we realized 2 things. First is nobody would want to see me or Tariq in Speedos on a beach. And secondly, it was raining, so we ended up doing it at a mall. But if he was here, and he is very good at presenting, he's in Vegas at the moment. He just did this yesterday, and I'm sure I haven't mentioned it, but GPT went down yesterday for like 4 hours during his entire session. So he was like, where we got literally blocked from using it because it's a university, and obviously they just outruled ChatGPT because otherwise none of their students will do anything. They literally was dependent on somebody who, if you read his post, it said they used a Raspberry Pi. Now, we've gone down the Raspberry Pi route before, and it is about a token a second. So you can do it on a Raspberry Pi, on a 4B, but you would have literally be waiting 20, 30 minutes per response. So this is kind of the pain of NPUs, and why they're so important now is because neural processing units perform so much better than regular CPU. So, everyone's laptop here today would be able to run a large language model. No problems. A small one, maybe an 8 billion one, right? Or a 1.6, no problems. How long are the responses? For those in the Mac, with the Mac logos, it's finally good to be on a Mac. They're going to get a response sub 30 seconds, right? Which is nearly acceptable, right? I don't mind waiting 30 seconds for a response. Us Windows people, because they are bringing back the I'm a PC, I'm a Windows thing, advertising again. The PCs in the room, unfortunately, you're probably going to take a minute, twice as long because it's CPU. Annoyingly, it doesn't matter how big your CPU is. It doesn't matter how many cores you've got on that CPU. It diminishes after about 8. So there's no real value, even if you had a lot of compute, to use compute, which is why NVIDIA stock price went through the roof. It's also why both AMD and Intel are releasing NPUs this year. And the NPUs, which is why NVIDIA are already starting to get in there for some good kicking, the NPUs that will be on Intel chips and AMD chips and stuff won't be super fast, but they'll be very energy efficient. So you'll be able to get responses within 15 seconds, but that's enough for a phone, right? If you're laying down and you're bleeding out, you might want a faster phone. That might be a new justification for getting a faster phone.
Like for the foreseeable future, I think it's still better to get a Mac with a new silicon.
Well, I say that. So this is, as you can probably see, this is a M3 36 gig Pro, and it's still pretty pants. So, there's no kind of justification in going and buying a Mac today. However, if you want to buy a Surface Book that comes out next month from Microsoft with the Qualcomm ARM platform on there, that's going to be the best $600, $700 you've spent in a long time, because that is going to be, for the foreseeable future, is going to be a rock solid platform to run on. So Windows, what was Windows 12, needs 16 gig to run Copilot. So, first time in a long time as the minimum requirement's gone in, and that's 12.4 gig of addressable space is running Copilot in your machine. So
They're running it on RAM, not on GPU.
So they're unified memory, but the Intel chips, in essence, are unified memory as well now. So that's, in essence, why they've changed the architecture is VRAM, which is why graphics cards were so expensive, super fast memory, DDR5, normal memory, which is in your PCs, DDR4, the M series, which was slightly ahead of the curve, is unified memory. So it's able to swap out primary memory for, in essence, graphics memory. It's a bit geeky, but that's why Macs are so good. And they've got, in essence, within their core architecture, they've got NPUs which are allocatable. Same thing now with the Intel Ultra things, that they've got dedicated NPUs. But again, NVIDIA are already giving them a big shout to say, you still want an RTX card if you want to do Copilot Plus, because you're going to get things super fast. But what the use cases are things that aren't super important to most users. So the big selling point for the Intel and everything else is it can do the overlay of the skeletal structure. If you remember the Kinect devices back in the day with the Xbox, that little Kinect 3, most cameras now to do the ability, any camera that has the ability to do biometrics, i.e. facial scan to unlock, in theory is a stereo camera. So if you've got a front-facing camera on your iPhone, it will be able to take, in essence, a LiDAR depth image, which means that you can also overlay skeletal structure. So therefore, for things like MSK, for workout and stuff like that, you'll be able to just put your phone there, and it'll be able to overlay it, and you'll go, oh, you've got like an issue with your back, you need to stretch a little bit here or stretch there. All of those are the use cases they're trying to get people to use it. It doesn't use LiDAR, but it uses a depth camera, which in essence just means that it can render over the top of it. So LiDAR is on the Max phones is obviously designed here to do it. And then if you've got any of the beta versions, you'll see there's a little button here which turns on the Reality Pro recordings. So this now is actually in 3D. So in the old days, when 3D cameras came out and we all had 3D TVs with the 3D glasses, the new iPhones actually have used the LiDAR to overlay a 3D landscape. So in the future, if you think of Minority Report, where he sat with his kids dancing about, you'll be able to do that. They'll be able to generate holograms off the area you're in. It'll map the seats of this view now, and as I move left, it will then map the seats again. And in theory, in 5-10 years, whenever I've got my thing, I'll be able to recreate walking around this room based on the LiDAR information in a 3-dimensional space. So that already exists if you get... Yeah, but you can also use it in an Oculus now. There's a retro way of doing it going across. Not that this has anything to do with GANs, by the way, but we just thought we'd say that. But it was a detour off Tariq's great thing. So everyone, has anyone not been on thispersondoesn'texist.com? Attempt at being rich. I wish I could be. Why can't I use Alt Tab like you can in a PC? I love this. It's like there's so many people who then add in websites that are not the legitimate website. Every refresh that I get is a person, right? Now, the thing with the GAN, which is what we were just putting on the previous slide, is there's a there we go. Just so I can learn my own slide deck. There's two elements. There's the generator, and then there's the discriminator. Now, what in essence the discriminator is doing is it's rejecting every variant off the image until it passes all the criteria that it can't know that it isn't a real image. So if you say, for instance, ask the generator to create a bird, the first iteration will be, I'm going to do, it's got legs. And then the first version it's got 6 legs. Oh, crap. It then rejects it. And then it'll keep on redoing it until it meets all of its specifications of what a face should look like, what a image should look like. And once it's not able to tell the difference between the generated one and a real thing, it then lets it through, which is what you get here. Now, the reason why this is so quick is obviously there's a threshold, and that threshold might be 96%, which means that there will be certain telltale signs that this person doesn't exist.com. And I must admit, I can't spot, well, a necklace here isn't on the other side. So unless you're just wearing it on one side, I would have probably rejected that.
The most obvious is around the irises. So the eyes always are very blurry, murky, and you cannot see the irises are not very well defined.
Yeah, the Mona Lisa is equals kind of worrying, but there's a reflection in eyes of the wider world, and that's where I guess years of ray tracing or whatever in the future will have the image of what the person's looking at as well. Then the reflection in the eye will be that as well of someone holding a camera. Then maybe the area, but it is pretty good, right? And refresh. Now, what Microsoft have done, which is slightly even more worrying, is oh dear. And that's because the image on the right-hand side won't have gone through the filter, right? The main one will have passed the filter. The one on the left wouldn't have been done. It's only looking for one person in essence. It is. It's noticeable. And I think this is kind of the slight challenge is that.
Yeah, but the thing is that you really need to look for it because at the first glance, it looks like a real person. You just need to know what to look for.
Yeah.
That's the difficult thing.
And so what Microsoft have done, which is really, really worrying, is they've done that, but then they've overlaid that into a full person and then given it a full characteristic voice and everything else. So in theory, they can generate human avatars which are nearly as identical as unique human beings. So in theory, if isn't long until, in theory, you're having a conversation with a doctor and he, she, they, them, you have no idea whether or not that's just been generated for that one time only to see you, or it's a real person. And it's slightly concerning, don't get me wrong. And so there's a couple, and I will show you later, but there's the technology which is being used for deep fakes is now available on some of the, I'll share the Git repositories for them. And the one that I use, which is, so I use Focus for easy diffusion, which I'll show you in a second. And then another one, which I'll show you, which does the replacing the images. So what I'll do, occasionally, what I did for a laugh on my LinkedIn is I got a picture of me as a woman, and I just converted me in real time. And then every frame just morphed somebody else's face onto mine. And so about, I think it is, yeah, it's the XL version of that, but it's the same technology that, unfortunately, in Russia, they started using Bruce Willis. I don't know if you've heard this thing, but they've used, Bruce Willis promotes all the mobile phone brands over there, and they've, in essence, deep faked him. And because of the copyright issues, they can't, Bruce Willis and his family can't shut them down. They've got in essence, their IP. Now, what's quite interesting about this is you kind of, even though now you're going to say, well, that's really obvious, is that Keanu Reeves was the first actor to actually ask not to be digitally changed in The Matrix, ironically, without his authorization, because he saw what they were doing. He kind of said to him, look, I want writing into the contract that you can't use my image unless you pay me for the image. And we've also all seen, everyone hates Joan, is it? Joan is awful. There we go. So Black Mirror, everyone seen Black Mirror? So Black Mirror, which if you watch that movie again, as you walk in, the first where her office is my old office. So it's in Ditton Park in Slough. That's the office that she works in, which is not interesting at all, but is for me. But yeah, so Joan is awful, which would have been a perfectly legitimate story case until they got to the quantum computer at the end, and you kind of go, no, that's not valid. But the idea of literally recreating an entire storyline based on your day and then dramatize it and then watching it on Netflix isn't that far away. And so the predictions which have been put in at the moment are saying that you could be going to the movie studio to see Matrix 6, where you are Neo, and your family and friends who you choose to be in the movie are in the movie with you, and it's generated just for you. So it's not that far away. Equally, it's not that far away if you use runway.ai today. You can use it for free. You can type in, and I don't know if you've seen the Star Wars one, but someone created a Star Wars trailer for a new movie, and it just looked like they just produced it. It was absolutely flawless. Whereas usually when you see this stuff, they've all got 8 fingers and 12 hands, which is fine if you're doing a promo for a Star Wars trailer. It's probably not if you're trying to do Bridgerton or something, right? Bridgerton might be all right, actually. But it's not that far away. But you've got to think about it. This GAN process takes quite a large amount of processing, which is why it was reserved to, again, RTX kind of cards. But in actual fact, if you're doing this at 60 frames per second, you're having to generate 60 variants off this image, which have to then go through this process. And that's why it's so processor heavy generating video, because every 1 second, in essence, is 30 or 60 images. It goes through this exact process just with a small variant on the image. But yes, of course, it's trained with real images first, and then it generates the fakes. So you can, but at no point are you really going to say, oh, actually, I'm going to start using TensorFlow or something to generate my own models, because it's not really valuable, right? So the other interesting use case, what you get with GANs, is around what I'm going to call the VHS Betamax to 8K area. So you can, in essence, take an image, a low resolution image, which really annoys me in every movie I ever see, where they take a CCTV footage and it's just like really blurry, and then they zoom up and then go, oh, look at this. It's wearing like a little icon ring with a name tag on it or something. You're like, what? How did you do that? But this does do this. So super resolution GANs will take it and run it and process, in essence, an image to a much higher variation, but it is literally taking that base image at 640 by 480 and then realizing those plants, it knows what a plant looks like. So it's generating what a plant would be to then allow it to be 8K, 12K, huge resolutions. So it's very clever how it does it. The same as it's got this iterations is that actually an image will have multiple iterations on its system. I'm now going to fall into the hands of the gods for this one, and I'm going to load. Whose face can I borrow? Can you send me a picture of your face on Slack, please? This is where HR get involved again. Back to Python. I'm so not used to using terminal. I always forget that it's case sensitive as well. Two seconds. Okay, so I'm going to use this this app, which I'm putting across here. If anyone wants to see what it's called, mainly because I'm thinking. So this is in essence easy diffusion, right? Is what it's using. And so you mentioned Midjourney, which is pretty much the same thing as this. Obviously, I'm going to be running this on a PC, on a Mac, so it's going to be a little bit, I say bumpy, but we'll see. But it's something you can try. It's hours of entertainment if you have friends around. I say that.
Pictures of your friends.
Pictures of your friends, yeah. Have you?
Embarrassing pictures of your friends. Ah, you are going to be embarrassed.
Okay. Apparently an ultra high. So you put it onto. So we have Philippa's photo. Go. Okay, 192.127. This makes me realize that our implementation is never very good at using the correct ports. 7865. Okay. Right. As everyone notices, everything's always built with Gradio. So is our platform now. So get some advanced stuff up here. So you can pass an image to it. In this case, I'm going to borrow the image that I've just downloaded, hopefully. Oh, look, I've just found Gareth. I think you've just been saved. So image prompt. Oh, wait a second. That's not right. So upscale, no. Image prompt, yes. Advanced. That's it. Okay. So I take a picture of my boss. Don't do this at home or on a live stream. There's two things. And then, as you can see, there's some weightings here around stuff. And that's why I said it will wait to a certain time. So at the moment, it's stop at 90%. It thinks is 90%. And it's got a weighting of how much of the image it thinks it's going to try and use. So I'm going to wang that up a little bit. I'm all right at stopping about there. And then I kind of want a realistic image. I'll do two images. And then anyone spell Poseidon? That's the next big question, isn't it? Poseidon. Okay, and I'm slightly concerned that Poseidon may or may not be wearing clothing. So please. Okay, so the reason why we're doing this is what you'll see is each image that it generates, it will create a variant. And what you'll see as the variant swaps, because it's so slow, you'll see it change the image and keep on doing versions, which in essence it's rejecting until it can actually, to a certain point, get enough up there. So it's now offloaded the large language model, the GAN to my GPU. So it's moved this to a GPU. There is no GPU in there. It's moved it to the NPU in essence. So that moves, in essence, 6 gig of an image GAN generator to my memory. Now, obviously, this moves from primary memory to secondary memory. Then it will start running the actual prompts against it, in essence, for what we're going to generate. So hopefully, we're moving from memory. Yeah, it has. And so it knows what Poseidon looks like. So that's where it's going to kind of start. But it also knows that, in essence, it needs to face swap my boss onto it. So it starts architecting the facial structure of the person onto the image. The second thing is Poseidon obviously is god of the water, thunder, and also horses. So there's a good chance that there might end up being a horse in this image because it's trying to, in essence, do a word search against Poseidon. Coming back, thunder, Greek god. It also, if you read the Wikipedia page, it then says there's an equivalent. Now, this is slightly worrying because, you know, I can kind of see Gareth's head there, like lacking a bit of hair a little bit. It looks like he may or may not be underwater. He's now wearing a pirate eye, which is always really good. Looks like he's got a fishbone. He's definitely underwater at the moment, which is slightly worrying. That's a good question. I'm glad he's got a shirt on there. That's the only reason I've still got a job. He's got a fish though in his hand. It's just gonna. He's wearing a skirt, which is, you know, is a design choice he's allowed to make. But you can see already the word association of Poseidon sea, it's automatically made the assumption he needs to be in the water in this case. He also somehow needs to have a fork. See, it's now decided that that fish shouldn't be part of the stick, so the fish has disappeared off. But you can kind of see how the GAN is going through that thing. And obviously every image that's going to be created is completely unique and no two images are ever going to be the same.
The Poseidon that you provide doesn't is just text.
Just
so it goes over the internet and searches images and
well,
information.
Yeah, it does. Yeah. So this will use in essence a very small. So typically you have you have a number of different libraries as part of LangChain and PyTorch that it will load up. One of them will be, in essence, what is Poseidon? And it's going off there and getting some keywords. Now, interestingly, a story that I'm not allowed to tell is that there is a Spanish influencer on Only Something, which also is a website I can't talk about, who is completely AI generated using this platform. And her prompts, her, he, she, them, whoever they might be, literally has a list in here of no makeup, just out of gym, yoga pose, blah, blah, dimples, whatever. She face swaps a face to keep the consistency of the face, but the rest is just a hugely detailed prompt. So in essence, this person who gets 25,000 a month on that website is literally a great prompt engineer, and that's all. Someone should hire them, right?
This is not running stable diffusion.
No. And now he's got his top off.
Oh,
there we go. Now we've got a problem, right? This is where HR has to ring me up. Stop using stable diffusion. Now, at least he's given him a six-pack, so he's going to be all right with that, right? Suddenly, it was okay. If it had come out looking like me, which it looked like it had done, then he would have not been happy whatsoever. What's he doing?
No, it looks more like cooking.
This is where the conversation goes completely off-piste. He has a trident this time, yeah. It may turn into a fish again, though. That's the problem, isn't it? But once it's finished, you can probably see that the resolution is actually quite high. So obviously, if you put into a high resolution with high quality, you can get a very detailed image. And what the skill is with this is you've probably seen, which is what was my best Christmas gift I got an extra finger on my stuck-on finger. So that way, whenever you get tagged with a photo, it automatically detects that you're not a real person because you've got an extra finger. This is the same kind of problem. Is if, for instance, Gareth, who's still wearing a shirt, which is to work, right? If you wanted to refine this, but everything else about it was perfect, apart from he's wearing a collar. What you could do is just highlight that one component and then ask it to re-engineer that one component. So in actual fact, it won't rebuild the entire image. And this is where people are getting better at when there's 6 or 7 fingers. They just tell it that that's a hand and then regenerate hand. I'm impressed he's turned up for work in a suit still with the six-pack's now gone a little bit there. This is the stand-up next to the waterfall. And then once the waterfall's gone, then it's... in all fairness, his image is available on Google, so I feel like it's not his fault. But yeah, you can see there's some good photo editing, waterfall. Not sure the water would be particularly like that. It obviously looks like it's a volcanic kind of area. Nice trident. Right, so that aside. Yep. So back to the theory of the stuff. You can see that the iterations of the image as it went through, it was going, no, that's not right. No, that's not right. No, that's not right. Until the real generator, the discriminator, would actually then give it an okay. So each time it's sent through, each iteration it's coming through, and we set that to 93. Now, obviously, if I had set that to 99, this might have been 150 iterations before it gets to the final photo. So part of it is you have to make a decision of either speed, accuracy, or quality. But it is, in essence, looking for certain key components. And that's why if you're really specific within that prompt, you get really good results out of it. If you just put one word and remember, a lot of the words that we use in English aren't necessary. Like if I'd have said, Poseidon, draw me a picture of Poseidon, obviously all that was just extra words that I didn't really need to use, right? It only wants the key words. We looked at this person doesn't exist.com. So obviously I keep on going on about graphs. And the reason why I can go so much around graphs is knowledge is so much easier represented when it's in a structural format with the relationship between the entities than if you're just giving it in a structured format. Like we would say, well, that's great. And obviously this isn't a great example, but if take that as a CSV file with ID, Jira ID, and ticket type, whereas there's a relationship here saying severity high, severity medium, severity low. We all know, based on popular psychology, that nobody changes the severity, right? They leave it at the default value. So is everything a medium? No, but you could probably learn here that if you read the issue, the platform is on fire and all our customers can't get online, it wouldn't allow you to go to medium. You'd have to select high, or it would just change it too high for you. Yeah. So you've got the extra skills. But you go into another project, another Jira instance, and they've customized theirs to severity high, very high, or 5 different levels. How do you normalize reporting? If you wanted to say, well, how many tickets are between 1 and 10? You know, how do you provide a rating that's flexible? With a graph model notation for each team in each project, you can still understand the extra large to large mapping situation. With this, you've just got, we don't know that 3s are medium or 5s are high. You know, part of it is there's no structure. Equally, we don't know the relationship between priority and impact because they're mean different things to different people. So graph notations are just so much easier to provide information that makes a lot more structural sense than if you just try and put it into a vector store. And so think about GPT's whole in GPT is it doesn't use graphs. It uses vector. It just uses flat file formats. This RAG architecture will give you the ability to actually give it understanding and interpretation and learning. So what we've done to kind of give you a bit of an idea is we've built a model which is in our system, which in essence is this, which actually talks about testing. So it understands equivalence partitioning and equivalence variation are related to each other. So therefore it understands the relationship, and then it understands, well, how do I do equivalence partitioning? And then it knows the method behind it and how to do it. So part of it is the relational information is much more powerful. And the way that we do it now, and this is why, again, RAG, I keep on going on and on about RAG, is because this is tester knowledge, right? So this is, in essence, equivalence partition in classification trees, whatever else, you know, all your patterns that you know as a tester. This is your organization and how your organization does stuff, right? And let's say you work at Domino's. Domino's have their special sauce, let's say, that makes them different to Pizza Hut. So therefore, how they do pizza is completely different, right? And I used to work with Domino's, so I'm going to use them as an easy example. But Domino's in the US, which is in Detroit, is their head office. They're a big open source landscape. Domino's in the UK, massive Microsoft stack. So their mobile apps and their applications are all built on different stacks to the US guys are. Equally, when I was working with the guys in the US, they had 3 things which were completely crazy. One of them was a promotion which was called Find Me, Feed Me, which was using your GPS data location and would come to wherever you were. And the idea was if it was a park or an outdoor event, you know, they would come out and deliver the pizza while you were sat at the festival. However, that was about the same time in the US when those clowns started coming out of the, you know, the woods. And suddenly all these poor, you know, pizza people were going in the middle of fields and people had moved on and not had a signal on their GPS for 3 hours and they were lost up a tree or something. The other thing, which I was part of, was the Mustang. All Fords run Microsoft embedded software. The app, which I thought was actually quite good, which I helped them do, was you could order a pizza whilst driving your Mustang. And literally in the US, the advert was someone driving at like flat out maximum speed, ordering their pizza with the infotainment system. I was thinking, there's a lot of road traffic violations there, right? You know, but the great thing about it was you'd order your pizza and it would only send it out to you to be delivered once you'd gone into a geofence of your local area. So you'd geofence back to your house, then it'd send out the delivery. So you'd order your pizza, but your pizza wouldn't turn up until you got home. which was a nice idea, right? But we're just talking pizza here, right? This, in essence, is your company's IP, your stuff that only you guys do and nobody else does. This is the industry. It's the industry you're in, right? Which in Domino's case is, let's call it the pizza industry. We're not in Italy, but it kind of feels like it. And, you know, that is some basic stuff, like what combinations go. Like, for instance, if I was going to say, put pineapple on your pizza, to me, it's like you shouldn't be allowed in Italy. However, half the people in this room will say, I love having pineapple on my pizza, right? But there's a logical thing there about the fact that, you know, pizza and pineapple goes really well, right? So, and I would say, because I've been in their test lab here, that actually a tandoori pizza is the best one they ever made with onion bhajis on it. Never went into production because 5 of us said they liked it, 5 of us said they didn't like it. But, you know, part of it is over here, onion bhaji tandoori pizza, not really a pizza, right? And if we're looking at that kind of discriminatory thing. Now, why am I saying that? Well, that's the industry, that's the testing domain, and that's your company. 3 separate informations, 3 separate graphs. This shouldn't be outside your organization. So ChatGPT will never know about the special source that is the underlining, you know, React Native app platform and point of sale systems and stuff that you use and delivery and, you know, actually how they make the dough and stuff. That's all your stuff. So that stuff, the only way you can get that in is by feeding it in locally. Now, this is why I advise people to use a local GPT instead of using a remote one, because you can pass that information in, you can pass that information in, and you can also pass the industry information into it. Now, there's a few caveats on this. The first thing is in essence, I'm not going to use the word overtuning it, but, you know, by giving it too much information to narrow its field down to be so specific can be quite restrictive as well. It can kind of go the other way. If you provide so much in here and then ask it to do something that's slightly outside its boundary, you'll find that it keeps on finding information here, doesn't really go out to the wide world of knowledge as well. So there is a disadvantage of doing it. The other advantage, which I love, so the misconception about ChatGPTs is a GPT should always tell you where it gets its information from. So you probably find using, I don't know, LLM Studio doesn't do it as much. I think it might be an option you can enable. No, you probably can't actually. But the solution I'm going to show you later, if you upload it 6, 7 documents, it'll tell you where it found the information. Because a large language model is very good at telling you where it found the information. It's just, obviously, Sam's disabled that because it would say stolen from Philippa's hard drive, you know, and then people get really upset, right? So it doesn't tell you where it found the information. That's why everyone doesn't trust it, because it doesn't say I stole it from Wikipedia or I stole it from archive.org from 10 years ago, right? You know, part of it is it did that, it would be in a lot of trouble. But actually, large language models will tell you exactly where it found the information and where it based that information on. And that becomes part of, in essence, the fluidity score and what its trustworthiness is of the response. So what I'll show you later when I spin ours up for a second is it'll tell me that it found it in defect 123, which it found on my Jura one, but it actually also found that in my Confluence page, I'd put that it should only retain the data for 2 days. However, this is saying that actually it's retained it for 3 days. And so it'll show me the 2 sources where it found it from, one which was Confluence, one which was a defect what I'd raised. And then it said, there's a mismatch here. So when this change request came through to change it, the system's now fixed, but no one updated Confluence. So it's actually quite useful because you can then go off and update the source, which is out of date, and say, okay, it should always be 2 days, and then your data's removed. So again, there's some real value in having all this linked, and that's why Microsoft want to own that graph, because that gives them so much power. And it also gives them, which is the slight worry on everybody apart from us in the room for the AI whisperers, is in the old days, we had single points of failure, right? Like Philippa, right? If we lose Philippa, the customer won't be able to get the magic source, right? Because it's all in Philippa's head. But what happens if Philippa becomes a graph? Not that you want to become a graph, right? But if you did become a graph, what happens is then Philippa's knowledge is everyone's knowledge. And this is the kind of worry now is, would you sell Jonathan.ai to work at 6 different companies and get 6 different salaries, but also have 6 liabilities of my successful or not successful implementation of those companies, right? I get a phone call saying, Jonathan told me you tested this, but you haven't. I was like, well, I'm on holiday in the Maldives. I don't know what Jonathan Bot 5 did. It's not my fault. But it notices that I still make mistakes, right? Because I'm a human. So I when I was, it wasn't Apple, when I was, and the last time on Microsoft campus, I met the guy who runs the HoloLens division, a guy called Ruben, right? And Ruben put together with Jobs and Wozniak the original iPhone. First iPhone came out, Keysight gave them, because no one was allowed to know about the fact they were making a phone because it's so hush-hush, Keysight gave them our equipment that did 4G, 3G cell connections, and they went off into a room and started building the iPhone, right? That's when the iPhone became the iPhone. So I walk into the meeting and Ruben's like, I'm waiting for him to mention Jobs. It's usually a countdown of maybe 2 or 3 minutes before he mentions him. But last time I saw him, he said, first thing he said to me was, we're the last people who are going to die. And I was like, okay. And he was like, yeah. He said, I realized that I may die before I'm fully transcended onto the network. And he said, based on talking to my R&D guys, that if I'd been a generation later, I would have most likely, if you've all seen Upload on Amazon Prime, or the movie with Johnny Depp called Transcendence, where he transcends his entire consciousness, we will be able to, in essence, upload ourselves in the next kind of unfortunate generation. That might be 40, 50 years away. I'm going to say it's 30 because I'm more excited about it. But with things like Neuralink and beyond, so actually on my old slides, I used to have brain to input, which is something which you can do now. So we've got a partner in Israel, which literally you wear a watch and it just takes the signal from your brain to move your mouse around and interact with the system. But you can also do brain to input in the sense of I can think of a cat and it will just create a cat. So part of it is that already exists today. It's not that far away. But then that magical question asks is, if you can, should you? And then secondly, back to Bruce Willis's point, if you create a digital twin of yourself, minus the ethical concerns and violations, and either upload it into a robot or whatever else you want to do in the future, minus all the sci-fi stuff, is would you want to? And then if it was going to work for you, there's 20 versions of you, which could be on every customer site across the globe, all helping them implement automation solutions. And then you get the salaries coming in. Brilliant. Why not, right? And that's the AI whisper of the future is, in theory, you could do 10, 20, 30, 40 jobs at the same time and only be responding back to the prompts of, Jonathan, I'm a bit stuck here. What would you do if you were there, right? Which I'm not sure. Philippa, are you sold on this idea or tempted?
I am ready to there, so I'm kind of worried.
You already got it covered. That's why you keep on turning up to multiple sites at the same time. You just, what do you say? Oh yeah, no, it's WebDriver. Yeah, we can do that.
The 6 salaries part of it sounds enticing.
It does. Well, it's the pension I'm thinking at the end is the win.
The disappointing part is that the upload part would just been, you would create a replica. It would not be a transfer of consciousness. So you would still die.
Yeah, and the other thing is if someone pulls a disc out and then you do die, or there's a power supply, or they didn't DR over properly, or you didn't buy the right premium plan and you got raised after 60 days. There's lots of upsetting things you could probably do. The more depressing thing is if you uploaded yourself and it was only like 640K, right? And then, then that would be a bit of a joke. I do joke about this because all our stuff for our normal queries are less than 640K. So I always think it's really funny because Bill Gates obviously famously said, no one will ever need more than 640K of memory, right? And I was like, yeah, okay, I get it. Back in 1982 or whatever it was. But now all I pass into these RAG queries is 640K of query data, and I'm sat there going, oh, he knew we were going to get this kind of architecture. He just was messing with us. We've got about 10 minutes before the break. So actually, once we finish this bit, which is actually only one slide, a couple of slides away, it's then going to be more practical, hands-on doing stuff. But I think a lot of this, I'm hoping it kind of falls into making more sense when you're trying to do the actual prompts and everything else. And the other bit, which I just kind of wanted to say, the reason why everyone's so excited about large language models is these two elements. Is natural language understanding has evolved, which is why it's able to do what it does. And when I say natural language understanding, the ability to send it a prompt and it understand with good accuracy and then actually generate a response that in theory is fooling you as the actual user has massively evolved. If we looked at the spike in the last few years, NLP is still only a subset of this capabilities here, which is natural language understanding. So things like sentiment analysis, people are very familiar with, right? So like I said, if you put your transcript in, usually it'll tell you your sentiment, right? Straight away. It'll say, oh yeah, Jonathan was upset, Jonathan was happy, Jonathan was whatever, right? It can quite easily understand that because it understands how the use of English, how you use the words and the meaning of those words. But this is really extended. Now, neuro-linguistic programming is what large action models are. So neuro-linguistic languages are a new language subset which kind of supersedes Python. The idea is that we've all been talking about NLP for a long time. People go, oh, well, you don't have to code anymore. You can just speak to it, right? And that is, in essence, neuro-linguistic programming. It's still logical sense, but in the old days, our thought process, which was what was behind here, was us talking about log into browser, sign up on Nike, enter email address, because we think sequentially, whereas now, neuro-linguistic programming is understanding what we're trying to do and just doing it. Like, why do I register for something when I could just hit the API? It's kind of that point of thing where it doesn't care because it already understands the system that you're doing. And this is why, misquoting the Agile Manifesto for a second, whereas if you read the small print at the bottom, which says, as much as we appreciate the stuff on the right, we appreciate the stuff on the left more. When it says working software over documentation, what it should have said is working software, and also if you've got documentation, then you can do neuro-linguistic programming, because you need documentation, because how else does it learn, right? It needs to be able to learn from documents. If you don't write any documentation, then what's it going to learn on? And so where in the old days we got away with not writing a very good story in Jura, now the better your story, the better your prompt's going to be, better, the system's going to be able to help you out. So part of it is it's going to kind of bring back that fact that if you explain it, you have to explain it for it to be able to understand it. The other thing is, people would say a picture speaks 1,000 words. However, if we were talking about current graph-based RAG architectures, we wouldn't include visual recognition. So you're probably thinking to yourself, well, on my Confluence page, there isn't just text. There's graphs and pictures and mock-ups of Figma or whatever, right? They're as equally as important as, in essence, the text that associates with them. So what we're doing at the moment is we're building, on my router, tired from walking backwards and forwards to this poor thing. This poor, unfortunate fish is vision. What we're doing is we're passing in essence, a large vision model to identify images. Now, there's an interesting point about LAVA, or large action visual models, is a large visual model is, in essence, adding a large language model to an image, right? Which is an interesting concept, because when we saw that picture earlier and you were saying the trident, okay, it understands trident. There's a trident in the picture or a fish in the picture, and it understands the relationship between water and fish through the graph, so it knows it's on the right way, right? The same thing is a larva. Computer vision's been around for such a long time. A large action vision model is more about this, is about the understanding of where I am. So I'm going to show you a demo clip of Microsoft's large action models later on. But what it does is, say, for instance, I'm asking it to play Taylor Swift's new album, right? All 78 tracks of it, or however many it is on there. How does it play Taylor Swift? Now, if I ask Philippa, she will say, well, I'll just go to Spotify because she's a Spotify person, because she's cool, right? I don't buy Spotify because I'm obviously, you can tell, I've got an iPhone and a Mac, so I've got iTunes. So how does the large vision model know what to be able to launch, right? It could, if it's on Philippa's machine, it could see the Spotify icon on her toolbar and then straight away go, what's that? Oh, it's Spotify on a toolbar. And then suddenly this image becomes Spotify. Now, if it's on my laptop, it's going to see in the corner the iTunes button, right? Now, if it goes onto Philippa's machine, it'll also see iTunes. You've got iTunes on your bar, right? Have you got Spotify in your bar? How good's that? But if obviously if both icons are on, if it launches the Apple one and realizes that I haven't got a subscription, Taylor's not going to make any money. So I want to play it. So it'll start iTunes, try and get to Taylor, and realize it wants me to log in. It makes the decision about, well, am I going to sign up for Apple? No. I'm going to then go to the Spotify one, and I'm logged in already as, you know, Philippa. So then it searches, because it knows it's on Spotify's interface. It goes and searches for Taylor, and then it starts playing Taylor's new album, right? So part of it is it's using the large vision model to understand the sentiment of where it is. However, how does it understand this? Well, this is obviously is YOLO. Anyone use YOLO? What does YOLO stand for? You only look once. So what YOLO does, in essence, is, for all us geeks in the room, is it does object identification in pretty much near real time, and it will identify everything that exists on your desktop at the moment. And what it will do is, like going back into the 90s, it'll actually give an XY position of each icon or object that it's identified. So it'll do what we call image classification, and it will look through and spot the Spotify icon and turn it into an XML file with the word Spotify and the area. And for the automation people in the room, it'll also describe the automation capabilities based on the type. So if it's a button, it knows it can single click or it can double click, depending if you're a Mac or a PC, right? However, if you use Checky, which is Jason's tool, Checky.ai, I think, and you ask Checky to test Spotify, I can tell you the second test that it will auto-generate will be triple click on a button. So he used to run the search engine for Google, and it's interesting because he did a comparison of what AI, the large language model, generated and what his best engineers at Google generated. And what do you think the answer was? Do you think one was better than the other? Anybody? I know it's exactly lunchtime. What do you think? Best Google engineers in the world, or his, large language prompts? Which ones are going to give you the best results? It's interesting because there wasn't actually that much overlap. Whereas usually you would expect there would be a lot of similarities between the Google engineers and his large language model, i.e., I know it sounds really boring, but to me, Google's got like a bar in it and a search and a I think I'm lucky button, right? That's literally all it's got. But when you overlaid them, there was about 20 to 40% overlap of what the large language model generated and also what the Google engineers generated. However, the tests that the large language model created, as far as Jason was concerned, based on his score, were better than the ones that the Google engineers had created. And it was doing these weird things like triple clicking buttons. And we know that button doesn't support triple clicking because it's single or double. So triple clicking does what? It just sends the request twice. That then sends 2 requests to the server instead of 1. It potentially overloads if more people are triple clicking than normal. This is why when our parents are constantly hitting the screen, hoping that it would get there faster, it just causes more, it just makes it go slower, right? So part of it is, oh, Seb, do you have a minute tomorrow, before tomorrow? Probably not. But what, in essence, you're doing with this, so before we go to lunch, is we're taking YOLO's XML tagging of buttons and lists and tables, passing it, you're getting ready for this, as a graph into the large vision model. So that way, when you do the prompt, in essence, it's saying, based on what I'm seeing, am I on a music player? And that would be a whole stack of values, what might be Mariah Carey, you know, Taylor Swift, all this on the front page. It knows it's on a music app. So part of it is this understands sentiment, this understands object identification, but hand in hand, YOLO plus large vision model suddenly means you've got contextual awareness of documents and diagrams that are embedded within sources of knowledge, which is really important because when we're talking about creating this, it needs to know if the input is an image, a code, a script, or whatever else. And this is also what's going to happen in the future, is there's going to be a lot more visual recognition. And that hopefully answers your point of how do you automate in the future is you can do cause and effect based on this. So if I press this button, does Spotify load? Well, I ask it again, what do you see now? I don't see anything. Wait 10 seconds. Oh, now I see terms and conditions thing. Okay, well, I haven't scripted accept terms and conditions. However, I'm a large language model. If you ask me, how do I get past a terms and conditions page? What's it going to come back with? It's going to come back with a response saying, scroll to the bottom and then click to accept, or hit the checkbox that says I consent. So if the I consent changes to accept, do I have an object identifier for accept or consent? No, I don't give a crap because in essence, I understand the sentiment of proceed, accept thingy. So I can navigate through it. I know if I click decline, I ain't going anywhere, right? So part of it is it's starting to understand because it understands basic navigation. So a large language model can actually but it has to be in a feedback loop, right? It can't just be create a standard script. It's when you run the script, you're asking the large language model, am I at the right place I should be? Or as it loaded up, and then it's modifying it. It's the feedback information back into it. Anyway, lunchtime, hopefully theory time finished, and we'll...
How does the action part actually work? Because, for example, like if you have first you start iTunes, see if it has an account or not.
Yep.
I think that sounds like a lot of weights and a lot of like all the apps need to have like a headless mode or something.
Well, no, because the thing is, time is the one thing that large language models have, right? So I talked about the idea of brute force. What was our AutoGPT's model was running multiple threads trying to solve a problem. Now, what they did with AutoGPT, which is the domain AutoGPT, by the way, is literally you can say to it, build me an app. You know, you saw the ChatGPT app first time they did it. It said, build me an app, which is a joke app, and release it into iTunes, onto Apple, right, App Store. And it literally wrote the code, built the pipeline, deployed the app, the IPA file, got the signatory, did all that. It just did it. Now, it's not magic. The 644 other instances didn't manage to get through that problem because they started off differently. They went onto AWS, tried to put an APK file for Android and then got stuck. So part of it is it kind of is this short-term, long-term view of the things, is that actually where large action models are doing is they're in essence spinning up multiple instances to try and test an application, discover it itself, but it's going to fail. Now, in a way, that's good for us. But that's the thing, what I think the opportunity is, what we've got to think about, is that large action models and what Sam's building is to replace people. However, you'll still need to build apps and test apps, but we test them by using them in essence. And so a large action model can take us through the point of where it gets a screen what says account exceeds storage or something. And you'll go, oh, okay, so this looks, I'll look at, and this is why we said recall, I'll look at recall and I can now see literally in slow motion where it went through. And then also I can see all the responses that have come out from all the different systems. And I can literally like rewind it and fast forward it like TiVo with all these logs of information of stuff. And then this is what I refer to as open testing, is suddenly you've got all these observability capabilities that will allow testers to say, when you kind of think about exploratory testing, you say, you know, go explore it. You know, Paul Gerard's viewpoint is that you, as soon as you walk away from your desk, it should start testing, right? You know, why can't it be testing while you're not using the machine, right? You know, it should just be able to do it. And this is where our job goes, is it's always testing. It just uses us as the human proxy to say, well, I found this. This looks weird. You know, why is it Spotify's not the right icon color? And you're like, oh, that is weird. You know, show me on that configuration. Oh, it's on Ubuntu, whatever. Oh, okay. I didn't realize that. Is it an issue? Yeah, it's an issue. Oh, I've written the bug report. I've added the severity. I've sent the code that needs to fix it in the Git repository, and I've allocated the developer because I know he checked it, he, she, they, them checked it in. So literally, you are part of the human evolution into it, but you have to be able to give it you have to navigate it on its way. And I think this is where we are. We're these kind of AI whisperers and navigators to be able to think, use the human brain creativity power to really think about where the fish can, what use cases the fish could do. So you might, I might not be Philippa, you might not be a security tester, but there's no reason you can't ask it to start creating some ZAP tests and go and looking at OWASP vulnerabilities and check out all that stuff. And then if it finds it, also go and then hire the right person who's the security person to fix it, right? So, you know, part of it is us to be able to ask the ideas, and maybe we're not, you know, a developer or a performance engineer or a usability expert or an accessibility expert, but suddenly we are, because we get all this stuff that we go into Google Lighthouse and try and run accessibility violations or whatever. Instead of knowing about all that, it knows about that stuff. We need to then think about it. Well, what's this experience like? What's the, you know, what does this happen if it's, you know, ChatGPT goes down? You know, what if this, what? And that's where the human is coming into the loop.
Where would you run this of tests? I mean, this sounds like resource intensive, especially if there's on a lot of threads and a lot of businesses.
Yeah, it's compute, isn't it? That's the whole thing. But, you know, this then asks you, what do you do with it? Because you can run it at the edge, right? And that's the interesting thing about this, is once you've got these devices with NPUs, you should, in theory, be able to do a lot of it in hypervisors and stuff like that. Anyway, let's get some lunch, recharge.
We haven't been notified yet.
Not been notified.
Yeah. It will be in a while.
Okay, well, let's have a look at the questions and answers that we got based on what looks like very many years ago. Yep.
Since some of those LLM platforms have, you know, the paid version and the free version, let's say, and for the paid version, you have usually some restrictions about how many. Actually, for the paid version, you have a cost per call, per query, let's say. And if we do something as complicated as the one that we say, that will skyrocket the cost, I guess.
Yeah, so I wouldn't, like I said, you know, the reason why ChatGPT is hidden behind here is I wouldn't use ChatGPT, right? You know, I think
this will happen to every.
288 seconds. You see, I would fail that, right? That is not a good user interface, right? This is Samsung.
5 minutes.
Well, 200, that needs a space in it, right? And then sec should be lower, right? Lower S, it shouldn't be in capitals. So as far as I'm concerned, Samsung, is it Samsung?
Yeah, probably. I don't know.
This is why you don't, yeah, it's Samsung. You don't build your own OSs, right? That's the other thing. That's why Google do what they do. But so typically, so if you were Paul, you would use private GPT repo on GitHub. I don't use that. I use local GPT because it's better. So it's just local and then the word GPT. You can bring that down onto your machine, any machine. Everybody's machine here would be fine with it, right? There's no machine. Your machine would be very good with it because it's got an RTX on it. But everybody else's, you know, it will do everything you need. Everything we talk about today, you can run local GPT and it will automatically bring all the models you want, or bring in, you can put files into it. You can do everything we're talking about with a RAG architecture for free, right? And so, you know, I would say with this, you can build it yourself. You know, it feels a bit DIY-y, but it's better to build it than probably pay for a premium subscription. Now, don't get me wrong, you know, I have a Copilot 0365 account, which I pay for with my own money, because I genuinely believe it's a productivity enhancement to myself that justifies the $600 price tag, right? But for Copilot for 0365, yeah, per license, and they make you pay it all up front in a year. But I've got a feeling, and this is not, don't quote me if it doesn't happen, but I think the new Surface devices will come with Copilot Plus anyway for free. So it's nearly worth buying a Surface because it's the same price as buying GPT Copilot for Windows. And like I said, for us, Copilot for Windows is going to be a magical experience because it's got large action models. And it's going to give all that extra power in there. Of course, Copilot, we all know of, is just GPT rebadged. Copilot for GitHub is just Codex T5 rebadged. And that's a subscription every month for developers. And there is other AI productivity tools. Like I'll probably go through this afternoon. Like I pay for probably 5 or 6 productivity tools that I genuinely believe are really useful to help on a day-to-day basis. And then in a way, they're worth buying. But in theory, everything that you could do, you should be able to do for free. But there is a caveat, right? Is that local GPT on, you've got an M1 there, you're fine. So they're like your machine there is going to be really good because it's got a GPU in it. If you've got a GPU, you're going to get so much more performance out of it. But this is the problem. Unless you go to your boss and say, oh, I need a gaming laptop, which is why Randy's got a new Alienware laptop. You know, because you need the VRAM, right, to do it. But you can also build it yourself, right? So I use an old T5 card or something off Amazon, which I put in a server, and I run it at home, and it's just ultra fast. Apart from it's so hot, like my room, I've got 12 screens anyway, and then I've got all my machines kicking out when I'm doing my large language models. It's literally like, it's like going outside in Greece in like all the time, right? In my room, it doesn't matter, you know, what it's like. It's just, it's horrendously hot in my room. I've got AC and everything, which I shouldn't do in a cold place like the UK.
I think the main downside of local GPTs is that you are limited in the capacity of the model that you're going to load. You're not going to be able to run a 70 billion parameters model on your laptop.
Yeah, that's the thing. It's like I said, I've got the card which I've got on eBay was about 80 euros. And they typically will have at least 24 gigabytes worth of memory, right? Obviously, if we were like super geeky, the best one for money is a 3090, which has 24 gig of RAM on it. Okay. And that retails at about 600 euros. So it's not a cheap investment. If you wanted to buy a generic, a consumer, what I class as a consumer card, whereas actually buying a CUDA card, which is probably the best way off eBay. And then you can go up to, well, you can't. That's the whole point. And that's why you need a large language model router is, yeah. Well, you don't need to run fine tunes. You can load them in and out, right? So the reason why our solution, which we built, will run all its models. So we obviously have this one. So we also have the 7 times 8 billion mixtural effect.
An engine which decides which model should be loaded, and then it loads the model and unloads it when it's done.
Yeah, but what we do is we run 2 models simultaneously, and one in essence is the input type, and it's like one's a receiver, one's the input. So both of these models are loaded into memory. Now, obviously, if I was 12 billion on this side and 12 billion on this side, that would be the maximum I'd need. But for instance, we had a customer last week who didn't have any CUDAs, didn't have anything, just had primary memory. And obviously it's slow in primary memory, but in theory, you could in theory run that on 32 gigabytes of primary memory. It'd be horrible. Yeah, but the thing is, it's, you know, so the way we do it, we'll talk about it later on just as a kind of a use case. But like this question here from whoever this person is left over from whatever last session we did is like the example we ran, which Philippa knows about, is like we did an example with a NATO document, right? And so NATO do, as you'd expect, if you remember the good old days of requirement specifications, they'd write these huge requirement specifications. And they're about 700 pages, right? Now, back in the day, about a year ago when we started playing with that thing under here, right? We would give this NATO document to ChatGPT, and then we'd say to it, how many requirements are in there? And it'd say 7,152, right? And then I'd say, no, that's not right. Try again. How many is on there? Oh, 8,561. Are you sure? Oh, no, sorry, 9,850. What? And I'd be like, every time it would just come up with a random number that was not even close to what was inside it. And this is what we would normally class as hallucination, right? And people complain about hallucinations, but hallucinations are failure of the architecture you've used, right? If you're giving it an unstructured document and asking it something it contextually doesn't understand, there is no way you're ever going to get the right number out of it, right? So we hired a whole stack of Apple engineers, and strangely enough, no large language models were hurt, but you know, part of it is the ingest processed would then, in theory, so what we did is this was traditional ML, not magic large language models, is SRS documents have an ISO 29, whatever standard against them, and they also have an IEEE standard against them. And if you read the IEEE document thing, it tells you the structure a requirements document should have. So we created a process that in essence kind of ingested it, but also understood what was what. So this is why, again, why I talk too much about graphs, is what it was doing is it was in essence using the table of contents as a map of navigating through the document. And within this famously known NATO document, it's got 6 applications that exist. And I'm not calling them applications, I'm calling them systems, because that's what it is, right? And as we all know as testers, 6 systems is complicated. I would class that as an ecosystem, right? But the ecosystem relates to other ecosystems, upstream and downstream, and some systems don't have access to each other, right? And that's like any modern architecture. So the only way it would ever be able to understand the NATO 700-page NATO documents is to understand the systems that it's talking about. To do that, it must then understand what is system A, what is system B, and how does system A respond to system B. So it has to create this map of the system. And like you would do as a human, you're looking at it and you're thinking about what it is, right? We gave the example over here when we were just during the break. We were saying Uber, right? And I don't need to go onto the Uber app, but I know that the website's going to have the rider and the driver side. We talked about, we also know that the customer app is going to be different to the driver app, right? And, you know, I could probably, without being, even though I'm a massive Uber user, so I can't really use that as the greatest excuse, is I could probably go through into some of the feature level specifications, which are just not even written in there. Like, for instance, you probably know, which I think is one of the most controversial things Uber ever did, was it did the whole testing if you're drunk thing, which allowed people to reject pickups, right? So if you're holding, like I was last night with Carl, if you're holding your hand and you're shaking, which is not good if you've got Alzheimer's, but you know, if you're shaking, it auto detects that the person may be drunk based on your gyro information that it's using on the app. So when it comes to the person, they've actually got the ability to reject it and not get penalties against it because it auto detects that the person may or may not be intoxicated. So, you know, but that's not documented in any help file. You know, it's not on the website, but I know the feature exists. But then I also know, how do I test that as a tester, right? And what I usually do is give it to Philippa and give her some money to go to the pub, right? But, you know, part of it is that isn't always going to be good at end user testing, right? And like I said, I know this because I did drunk crowd testing for Domino's. So we paid Munich university students to get themselves intoxicated and then use the mobile app on test flight, right? And now, interestingly enough, the app will feature toddle things that are in a higher, the buttons are bigger after a certain time in certain countries. So they also streamline the process. So the old way, before we did the drunk crowd testing, the old way that we used to do it was you would log in at the start, whereas they realized that people dropped in because everyone was too drunk and forgot their credentials. So what they did is they allow you to do all the ordering process and then only prompt you at the end for your credentials. And by that time, you'd already ordered 6 pizzas, 4 friends, added the toppings. You were already committed to the fact that you were going to get this Domino's thing. And then when it asked you for your username and password, it was nearly worth the time to go through it. So the drop-off rates became a lot lower. But that's the same thing. The features of the app look and feel will change dynamically based on the time of day in which geolocation to support higher success rates. Again, not a documented feature, but you know it exists. So part of it is, as a human, we know what Spotify should look like, right? We know it's got a search bar somewhere, right? We know it's got a play button. We know it's got a pause button. We know all this because we've got personal experience of using the app. This has the same thing, is it has to build its own personalized understanding of a system and any subsystems that it does. Until it has confidence around understanding the system, there's no way that it can map it and then understand that I'm asking how many requirements there is because it doesn't understand what I'm asking in the first place, right? And I think this is why the journey, what we're doing today, even though it doesn't feel massively practical at the moment, is really getting us into that mindset that we kind of want it to, we need to create a map. And it doesn't have to be sophisticated, right? It doesn't have to be in a graph database. It could be just, in essence, a state transition diagram. You know, literally you feed it in a text file, you start on login page, the next page is main menu or driver selection, the next page, and you just write it out as a text file and say, I'm going to give you a state transition diagram, and that's how it goes. The arrows mean it goes to a subsystem, you know, and it will understand that you're giving it a map to use the underground or something, right? Or not using the underground as a great example. But this is all we're trying to do. Is I think the implied idea is that a large language model has the knowledge and understanding, but it doesn't. In a way, it's like a child. You have to explain to it what you're trying to do, and only at that point in time can you then get a better result of what you're getting out of the back of it. It is, and the other thing is, like I said, a lot of what we're talking about here isn't really large language models, right? Is what's around the large language model, and if you, the reason why OpenAI is worth so much money isn't because of the large language model, right? So this is what we realized quite quickly, is that most of the clever stuff, like GPT-O, for instance, is what they refer to as function calls to other functions that they've built on top of the large language model. So the ability to understand audio, there's lots of tools that can generate audio and language. We've been using them for years and years. They're just other tools. But at the end of the day, what are we trying to do? Well, we're trying to translate the Greek to something that it can understand. And that's then the question. And this is the kind of the ultimate question, which isn't 42, is what is the language which a machine should talk to in, right? Because I kind of partially would say, oh, well, binary or whatever, but that doesn't really make any sense. You could say quantum, and then you make less sense. But what language should you speak to a large language model in it? Is it English, right? Is English the best language to speak to a large language model in? Now, well, that's the thing, is that the answer is always yes, based on the fact that OpenAI is trained on the internet, and the internet is X billion lines worth of English. However, I say this in the caveat of all caveats, is English is great at poetry and storytelling and all this other stuff. But because it's so ambiguous, it's actually probably one of the worst languages you could probably ever use. So what I always say to my guys, what language should you use? Anybody want to guess? Close. It's Klingon, because Klingon is the only language which is fully maths-based. Maths-based languages aren't ambiguous. However, do you speak Klingon? This is the problem. And Carl might speak Klingon, but he's in a superposition, right? So he's no use to it whatsoever. But Klingon, as you would probably expect, isn't enough training data. However, that plays to its advantage and disadvantage, because if the language Klingon is the language of choice, you can use that as a super language on top of the language to speak it. Now, I would still not suggest Klingon is the correct language to do, right? But I'm also trying to suggest that actually other languages are sometimes, language variants are sometimes better than the English variants. So what we do now, which is slightly depressing, is as soon as we release this, what did we get? Well, the first thing was, so obviously English, Spanish, German, and French are all basic languages that are supported by GPTs, right? They're just the standard ones that are, it's raining apparently, are basic languages that it supports natively, right? However, our first thing our customers said was, well, we want a Japanese version. And we went, okay. So we swapped out all the variant for language instructs into Japanese and provided them to Japanese. Which variant do you think was better performing at testing, English or Japanese? It's Japanese. Japanese has much better, higher rating of output of content than the English version was. So we were asking it to do testing jobs, doing the same kind of thing, and it was better in Japanese than it was in English. Clearer. Yeah, less ambiguous language. So the prompts, in essence, are the same. We've not really changed the prompt tuning. They're just, yep. Yep. It's definitely related to tokenization, because if you look at if you try and translate, you just use a standard translate on a Japanese transcript, then do the English version, you look at the amount of words that are used to describe something in the English one, it's a lot more, whereas actually the words are longer for the Japanese, but they're much more accurate. And I think there's something in there. Now, I'm not saying we all should learn Mandarin or Latin or whatever, but I think there's something, I don't know what it is. I'm just saying, I think there's something there with language, which you might find that Greek is better than English.
It's widely used, especially in tech space.
Well, it is for like code, you're right. I think you're never going to get out of English to Python as the language translation thing. But I think for testing, I think it could be close to say that you might be better in Greek or some other native speaking language than using English. But that's the problem is it could be the business language that's used as well. So if your documentation is all in English.
In the example that you gave, the Japanese model, did you use the same
Problems?
but the test, here's the food.
Oh, I thought we were breaking out to somewhere.
How many vegans we got here? None? Okay, so you have a choice then. It's either pasticcio or gemisa. It's like stuffed tomato with rice. Yeah, gemisa, and the pasticcio is pasta with some meat, ragu, besa. Yeah, something like that. Yeah, and ground beef with sauce.
Grounded meat doesn't quite translate, does it? Sounds like just meat that's been thrown on the floor. It's now grounded.
But the training data is not the same, obviously.
No.
Right? So, do you have complete control over the training data of your models?
Yeah.
And did you include maybe poetry, maybe some prose or something in the English versus the?
No, I think the Japanese data set came from our Japanese customers, right? So there's something around the training, but the problem is with most training sets now, you obfuscate and auto-generate more data based on the deltas of the initial set. So like 100 SRS documents isn't enough to train anything, right? You need a billion of them, right? So what you do is you take the 100 and then you auto-generate a billion for the training data set, and then you train it against the billion or fine-tune it against the billion, right? We had a larger subset of data for English than we did Japanese, but I think the quality of the Japanese was better. So like the test strategy documents were clearer. Also because I used to work at Hitachi. So Hitachi was a Japanese-based company, but they were very engineering focused. So they were always very meticulous around the language and how long they spent into engineering the stuff. So you might find that, like, I'm not going to say this, but Google was better than Microsoft, or Microsoft are not as good as Amazon, or Amazon are, and so therefore, in essence, it's your cultural surrounding of the level of quality that you then make the choice of.
So, and another question: do you think that